So we'll get started. So first we will introduce to you the Raspberry Pi Pico. So those of you who have the kit with you, right? So please utilize this. We will show you. You may have already gone through the documentation that has come with this. There is a PDF file. If you could actually send that PDF file to Dave service in the presentation. Okay, so it's there on the presentations. Oh, good. Okay, so you wanted to say something? You could probably say from here itself. No, you could probably say it loud. It will come here. Sorry.
So all the code that we are using will be available at our Neoware's GitHub page by today evening. So if in case you are getting the Raspberry Pi tomorrow, or even if you have it today and you're not trying it out, you'll always have a very clearly explained code that you can go through and implement everything step by step. So there is no need for you to worry even for the recording. You can just access our GitHub page and we'll have a public repository. And we'll put in all the codes with the same names that we are mentioning now. So you can just download it and like kind of plug and play. They'll have a lot of comments explaining what is what. So I think you should be good. Thanks.
Super. So we'll get started with this now. We'll first introduce the Raspberry Pi. So what you have with you is this board. Okay. I'm just going to quickly go through. Hang on. There is animation here, so I'm going to just do how many? 4 steps. Shall I leave it here?
Yeah, from the first page.
Because we are in this mode. Okay.
Slide before.
Slide before this? Okay.
So, hi, I'm Akshay. So I'm a data scientist with Neoware.ai. So first, let us look at what is Raspberry Pi Pico, why we chose it, and what makes it so special. So about the Raspberry Pi Pico, it was launched on 30th January 2021. So it's like very brand new, almost bleeding edge in microcontrollers. And there are many things that make it very special. So let us just look through them one by one. So the Raspberry Pi was designed, the Pico was designed by Raspberry Pi. So they are the pioneers in making single chip computers. And the Pi Pico is a microcontroller. It's not exactly a system. It's not exactly a computer. So the Pi Pico is powered by a dual core ARM Cortex M0 processor, and it has a 264 KB of internal RAM. The specialty of Pi Pico that makes it so useful is that it has many programmable input-output pins. And apart from, so these input-output pins can be very easily used to control appliances and lighted displays, and Pico puts the technology in the forefront when it comes towards this. So when you have other peripherals that are involved with almost all of the microprocessors, they can be very easily connected to the Pico and be run. So Pico supports C and MicroPython. So that gives a vast audience. So there are people who are hardcore C. So they should have no problems. People who are beginners should not have any problem, because Python is a very friendly language to learn. It's not very difficult. And so even hardcore veterans of Python should not have any problem, because it goes quite in depth. And so another feature of the Pico is that it offers UF2 bootable loaders in the ROM memory. So in the flash memory, if you drop any UF2 file, it will automatically pick it up and start reading it and installing everything that you need. So you don't need to go through the hassle of installing something and breaking our head too much with things. So the thing about Raspberry is previously they have been designing all of their single board computers with mostly Broadcom processors. So they have been using BMC 2835, BMC 2836, BMC 2711, etc. But so those are all full-fledged desktop kind of things. But Pi Pico microcontroller. So that is why it is so special. And given its price, it's like come on to the top of all of the microcontrollers that we have. So we wanted to choose the latest and cost-effective one. So that is why we are at Pico now. So now let me introduce Pico to you. So this is the Raspberry Pi Pico. If you can look at the edges, you can see some that they are cut in like semicircles kind of thing, and the board is not entirely flat at the edges. So this kind of a circuit board is called a castellated circuit board. So there are plated holes at the edge of the board. So this facilitates when you want to like put the board on something else and directly solder it, and then probably build another bigger unit in which the Pi Pico is playing a part. So this is like the main advantage of having castellated circuit boards. So these holes they create kind of a link between the module board and the board in which it will be soldered to. So it's like the connection, main connection for these boards, and then you don't have to rely on those pins that will make the Pico stand out of the board if in case we are like kind of soldering it onto those. So this is one feature. So next we have this is the Rp2040 microcontroller. This is the latest chip from Raspberry. So they are the makers of this board. So what the name Rp2040, it actually stands for something. So Rp is Raspberry Pi. So 2 is the number of cores that are present in the 2040 microcontroller. So 0 is the N0 core processors. So it's named after that. So 4 stands for if you log RAM divided by 16K and then floor the value, you will get 4. So we have 264 KB of RAM divided by 16,000 log base 2 and floor will give you 4. And the final 0 on the chip is for on-chip flash storage, non-volatile storage. So if you floor log base 2, so there is 0 of non-volatile storage. So log to the base 2, 0 divided by 16,000 will be 0. So that is how the name Rp2040 has come about. So this is the main controller that you can see on screen. So the black thing right in the middle, that is the heart of the Raspberry Pi Pico. So at the top edges, you can see that we have a micro USB with which you can connect it to a computer or a power source.
One second. Chanesh, can you actually go on mute, please? Because you are coming up as a speaker. Others are able to. I think, for some time, unless you have questions, I would request all participants to go on mute.
Once again, we request all the participants to kindly put your microphones on mute mode, please, and not to disturb the session, please. Kindly make note, don't kindly disturb the session. Please put your microphones on mute mode only in case if you have any specific doubt. You can use the microphone, or we encourage you to use the chat window, please. Thank you.
Yeah. And folks, no offense, I just wanted to make sure that everybody is able to view the screens clearly, right? So because we are trying to.
Yes, sir. Yes, sir. It's very clear. We are monitoring in different locations. It's very clear, sir.
Okay. Finish this, right?
So at the front end, we have a micro USB. So that will take about 5 amps of 5 volts of power. So you can just directly plug it in once you program your Raspberry Pi Pico. You don't need to connect it to. It's not mandatory for you to just go ahead with a USB port. You can just plug it in with a wall charger, and then it should still work well. So there is also a boot cell switch. So the main importance of this switch is that when you connect it to a computer, it selects like how the Raspberry Pi must boot. So if you have the boot cell button pressed and then plug the Raspberry Pi onto a USB of a computer, it would show up as a removable disk like how we see pen drives. So that is useful for installing all of the components that we need, like UF2 files and everything. We just drag and drop it onto the storage of the Raspberry Pi Pico, and it will automatically install it and then restart the Pi itself. So there's also an onboard LED, so you can see it highlighted in this. So after this, so these are the main features in the front portion of the board. So there's also another very unique thing about this. So they have debug pads. So these debug pads are used to run SWD debugging in the Raspberry Pi Pico if you have a very large code base. So we will not be using these debug pads right now, but we just to know what they are and what they are to be used for. So apart from this, if you flip the Pico on its back, you can see that all the ports in the Pico are named, and you can see like which port is what, and all of those details are there at the back. But unfortunately, if you have it soldered, we'll be placing it on a breadboard. So we won't be able to see it once it's on the breadboard. So you can have a look at it now.
So some of you who may have already received it earlier yesterday or today, you may have already placed the Pico on the breadboard, right? So if you have done that, then I think you should refer to this diagram. Keep it with you. If you want to take a screenshot of this and keep it with you, you should do that. Others, if you have not, then you should just turn around your Pico and you should be able to see these ports, right? We are going to make some references to these. So know what are those numbers, because in the code later on, when we are doing like 2 or 3 of these use cases, we will refer to some of these numbers, right? So just keep but don't worry, from time to time, we will, if required, we will come back to this slide, flash it, or we will give you precisely how to identify those exact places so that you know where to put your put your devices or whatever we are going to place.
So we also have a schematic. So if you can take a screenshot of this will be better. So the Pico has a total of 40 pins, 20 pins on each side. So all of these pins are completely programmable. So let us look at them in a bit more detail. So if you see, pin numbers start from GP0. So count starts from 0 and goes all the way up until 22 for now. And there are also ground pins. So these are 0-volt pins in which you can connect to complete the circuit so that you can have current flowing everywhere. So the GP0, GP1, GP2, all of these are in IO pins, general purpose input-output pins that are completely programmable. So you can see that the grounds are strategically placed. So the third from the top and third from the bottom is a ground, and then there are 4 spaces followed by a ground and another 4 spaces followed by a ground from top and from bottom. So the grounds are same on the left side and on the right side. So that is just a lower potential so that you can have the current flowing and complete your circuit. So the next pin number, the actual pin numbers are what is there, GP0, GP1, GP2. So I'm just referencing the my count of the pins 30 for now so that you can know which pin I'm talking about. So So we have pin 30 is a very special pin. So it's a run pin. So what happens with this pin is that if you are controlling your microcontroller from another microcontroller, say another Pi Pico, so this is the pin that decides if you should have this microcontroller on or off. So if you want to turn off this microcontroller from another one, you connect to pin 30 and then you can do that. That is the purpose of this one. So then we have another, a few more pins like 26, 27, and then a ground, and then a 28. If you notice from 26, there's a straight jump up ahead to 20, from 22, there's a jump straight to 26. So this is because the pins on the Raspberry Pi Pico are named after the order in which they are connected to the 2040 Rp2040. So these pins in between are being used for other things on the board that are not available to us. So that is why we are missing out a few numbers over there. So after that, it's 27, 26, 27 and a ground again. So let us leave 35 for now, and then we'll come back to that later. So 36 is a 3v3 out. So a 3v3 out is it provides 3 volt out for powering your components that are all powered by 3 volts. So it's an output pin that will give you 3 volts of current. So the Pi Pico so
keep this the remaining ones.
So the power 3 volts comes from the this is the main power that goes into the Pico also. All the other modules in the Pico are powered by 3 volts, and all the other GP pins are also 3 volts. So this comes from the SMPS that powers the remaining of the modules on the Raspberry Pi as well. So there is also a 3v3EN. So this is used to switch off the Raspberry Pi. So if you want for it to be turned off, you can like connect to that and then give a command so that you can switch it off. So the 38th is ground again, and then we have a VSys. So the VSys is 2 to 5 volt power. So this comes directly from the SMPS as well. So this you cannot you cannot stop power from this port until and unless you switch off the Raspberry Pi Pico. So this comes out before the power goes into the SMPS and gets converted to 3 volts. So above this we have another V bus. So the V bus is 5 volts and it's directly powered from the USB. Like the power that comes into the USB is directly coming onto the V bus. And then we have an ADC VREF. So the ADC VREF provides voltage and a current with which you can calibrate some of your instruments. And then there are a few more ADC ports. So these ADC ports, they convert analog signals into digital signals. So if we should need that kind of a functionality, we will be using these ports. You can see that some of them are coinciding with GP pins. So that's all right. So the GP pin can be a general purpose pin that you can program, and it can be an ADC port as well.
Okay, folks, it may sound a little overwhelming. For a few minutes, just please be with us. When you start doing 1 or 2 experiments, you will start understanding each of these components a little better. Okay. As of now, the key takeaway is you have a set of general purpose input output pins, roughly around 25, 26 of them. Then you have a handful of ground ports, right? 8 of them actually. So you can use these pins for you to close the circuit. Then you have a few analog to digital conversion pins. For today's exercises, we are not even going to use all of these, right? So today's idea is to introduce the board to you, use like 3 or 4 experiments for you to try and connect and start having a feel for the board, right? So we are going to, before Akshay starts with each of these experiments, we will probably do it in this order, right? We will first give you one exercise where we will ask you now how to connect, first to power up the board, right? So we'll tell you how to place the Pico on the breadboard first. Carefully place that. We will come to that in a moment. And then we'll ask you to power up. So those of you who are doing it along with us, connect your the micro USB power and bring up the board, right? Then we'll give you a small piece of code and tell you, how to switch on the onboard LED, right? So Akshay already showed you this LED, right? So how to switch on the onboard LED. Then we will ask you to connect an LED on the breadboard itself and show you how to program to switch on that LED. Then so that will be first a simple experiment, right? Power on, switch on the onboard LED, connect an external LED on the breadboard and switch that on. We will finish one experiment. Then we will pick up the second experiment where we will attach probably 2 or 3 LEDs and show you how you can quickly build a signaling system, if you will, right? Very simple experiment. We'll show you how to take the code, right? While doing this, we'll also tell you how to install MicroPython on the Raspberry Pi. Then using that, we'll give a small piece of code on MicroPython. You can deliver that code, and with that code, you can switch on a small signaling system. That will be the second experiment. Third experiment, we will connect a buzzer. We'll make some sound. So we'll try to switch on and make it do a small beep sound. That will be the third experiment. Then fourth, we will pick up a set of sensors, right? We'll probably take a temperature sensor and a humidity sensor. We'll place it on the breadboard. Again, start reading, right? So from the ambient environment, it will start reading the temperature and the humidity. We will show that to you on the screen. You can try and do the same thing there. That will be the fourth experiment, right? Finally, we'll show you something related to Bluetooth. It may or may not complete. See, you need to understand that the Pico, on one hand, it is a bleeding edge technology. On the other hand, it's an evolving ecosystem. There are more programs and more device or drivers to be downloaded, drivers to be installed, etc. So please be patient with this, right? When you are going through your learning exercise, not everything may work for you, right? So you may have to make sure that the connections are correct. It's a little sensitive, so you have to make sure that the connections are correct. You have to pay attention to the port numbers that you are using. So in today's exercise, we are not going to spend a lot of time trying to fix if you are running, if you are running into issues, right? You can look for online resources or reach out to us. We will try to help you offline. But if we start fixing or trying to troubleshoot each of yours, we will not have sufficient time. So we will keep going from here. Okay. So please hang on with us for I just wanted to set this ground rule so that you are aware, right? Let's go on.
Okay. So just a note of caution. So when you are trying to plug the Pico onto the breadboard, it would be you need to be a bit careful so that you don't bend the pins. And also, it's really important for you that not to connect 2 pins explicitly unless you are directed by me or any other project that you are following. So that would cause for the board to get short circuited. So you need to be very, very careful about this, and also not bend the pins as well. Otherwise, it will not go into the breadboard or it might damage the board as well. So if you have everything like the breadboard and your Raspberry Pi that came with the soldered pins, you would be placing it on the board right now. So you can place it such that
you can probably show it from there. A bit loud from there. So we are slowly moving into the experiment part, folks. So what Akshay will be showing on his camera, we'll mute from here. So for a moment, we'll pause the presentation here. You should look at Akshay's camera. I'm going to unmute here and unmute from there so that the speaker comes on that. Okay.
Yes, sorry.
So you should be able to see a screen. So in this, in the board that Akshay is showing you, he has already placed the Pico on the breadboard. Okay. So those of you who have received the kit, you would have received the breadboard, you would have received the Pico, plus you would have received other materials. You would have received a few LEDs, the sensors that we spoke about. So if you have ordered the complete list that we have given earlier, you would see like 6 or 7 of them. So first thing that has happened is he has placed the Pico on the breadboard very carefully. Okay.
So you want to place it so that you have 2 pins to spare on this side and 2 pins to spare on this side, given that you have the same size breadboard. Otherwise, if you have a different size breadboard, the only thing to look for is that these pins are on the other side of the breadboard and these pins are on the other side of the breadboard. So that is the main thing. So you can apply pressure towards where the pins are so that they can sit, and you can apply pressure over here so that you get it seated nicely. You don't want to apply pressure on the USB port because it's not very fragile, but still to be on the safer side. So you can apply pressure this side, and over here at the edge so that you can get it seated. It is a little bit tricky to get this done because the soldered pins will be a bit sharp, yes. So might want to get some protection, like say a cloth or something, and then somehow like without challenging the Pi too much, you can just gently, slowly, no hurry, slowly, please take your time so that you don't damage anything, and then have it seated on the breadboard like this. If you look on the breadboard very carefully, you can see that they have alphabets and stuff. So that can be useful for me to reference like which pin where we are connecting. But I'll try my level best to like reference towards how many pins down or how many pins up, or the number of the pin number or something similar to that, so that it might be a lot easier, because the what is written on the breadboard is kind of a little bit very difficult to read through. Yeah. So once you have the Pico placed on the breadboard, like we can go on to the next step.
Good. So I think we should get started with the first experiment now. So first we can power up the board. We can begin with that. Folks, one big announcement before Shri continues with the experiment. At 11:30 or so, we'll probably take a quick 5-minute pause. Right? Those of you who want to take a bio break, do that and come back. But we will keep going, right? Because I think for us to fully do the experiments and complete it, we will require some additional time. So the plan is to continue looking on till like 12:30 or so. Okay? And then we'll give you a lunch break, and then we can come back at 2 o'clock. So 12:30. So the idea is to keep going till 12:30. Okay? We'll try to cover as much ground as possible till that. We'll probably take a quick 5-minute break about at 11:30. Okay? So first step, we will go back to the board for a few minutes. I think Akshay says I'll unmute so that we will have to reduce the volume there so that it doesn't echo. I'm going to share my screen. We'll pick up the presentation once more. So now that you have placed the board, we'll try to go through this a little bit, understand the breadboard as well, and know some connection details so that you can try there.
First we'll install.
Awesome. Oh, okay. So this slide or the next one? Oh, okay. So we have plugged the Pico on the board. Okay. Next is the micro Python. Okay.
So about MicroPython. MicroPython is a very small, it's a tiny Python interpreter. So it's a version of Python that is tuned specially for microcontrollers. So so what is the advantage is that Python helps keep code very clean and clear, and you don't have to use very low level languages like C, C++, and then struggle. Python is very simple, so it appeals to all users, whether you're a beginner or if you're very well versed and you are still with low level languages. You can of course use C, C++, or if you're starting to learn just now, you can of course use Python, which is very user friendly. So now we will be installing MicroPython onto our Pi Pico. So I'll just walk you through how to do it in the beginning, and then you can do it on your own, and I'll switch over to the video so that you can also see. So first, you need to very gently and carefully plug in the USB port in the Raspberry Pi Pico, like the right side up. So it's a micro USB port. So if you flip the uh, cable upside down, it would not go in, and force is not the like best friend. So you can just plug in the micro USB onto the Pi Pico. So it's not as fragile as I'm saying. I'm exaggerating a bit, but just to be on the safer side, let's not try anything. So once you plug it in, you will be holding down the boot cell button, which I had shown you previously, and I will be showing you now. Then while you are holding it, while you're still holding it down, you will need to plug it in onto a USB port on your computer, and then you can just count up until 3 and then let go of the boot cell button. So after you let go, in like a second or two, you should see the Raspberry Pi pop up as like how you see a regular pen drive. So if you open that removable, it's called a removable drive. So if you open that drive, you should see a document called index.htm on that. So if you click on that, it would take you onto the Raspberry Pi's site, from where you can access the MicroPython tab. And from there, you would be downloading a UF2 file that contains MicroPython. And once the file is downloaded, you would just need to copy and paste it onto the Raspberry Pi. And as soon as the copying process is over, Pi will automatically detect the UF2 file, it will install, and it will automatically reboot. So your device will get unplugged, like you get that warning if you don't remove it safely. So that's okay. It's supposed to happen that way. So this is how you're supposed to install MicroPython. So let me come onto my screen. I hope everyone can see. So this is the micro USB port. I have one from Sony. You might have a different brand, or if you ordered from the Amazon link, I think they give you a micro USB port along with this. So you want to have these pointy edges at the top and plug it in. You can see that it will give you a nice click sound, so that you know that it's properly plugged in. So now that that is done, you want to hold down the boot cell button, which is right over here. This is the boot cell button in white. So you hold it down, and then I'm going to plug the USB onto my computer. And then we count till 3 and then let go. So after you do this, let me share my screen.
mute this one. Oh. So some of you who may have been actually trying to work along with us, you may have completed your MicroPython installation. We will have just dragged and dropped there. So next step is to download Thorny, which is the IDE with which you will write programs, and those programs can be deployed onto the Raspberry Pi. And so on the computer that you have, right? So people who are trying to look at it from a mobile, you may find it difficult. You'll be better off if you have a Windows, Ubuntu, or a Mac laptop or a desktop. You will be able to do these programs that we are talking about. Mobile, it may be a challenge. Okay. So next step is to download Thorny and install on your laptop or your desktop. Okay, so we are coming back to the deck once more. So we finished installing MicroPython on the Raspberry Pi. We also downloaded Thorny and installed it on whatever desktop that you had. And then the next step, yeah. So you go to thorny.org, download the version for your OS. So Akshay was actually telling me yesterday when we were preparing that we'll have to be careful about the version, right? Because it doesn't automatically pick up the latest version that is available. So you'll have to check for that, whether you are on Ubuntu or Mac or Windows. So check for the right version for your laptop or your desktop and download and install it. Okay. So on the laptop that we are using here, Akshay has already installed Thorny. So as usual, he is picking up with the first program, your Hello World program on using the MicroPython code. Okay. Because just we wanted to actually progress in parallel on both the hardware side as well as the software side. So he will show a little bit of software side. I will stop sharing. You go ahead and share.
So you want to Google for thorny.org. And from here, you want to choose the latest version. Like this is the latest version, 3.3.6. So if you are running Linux and you do sudo install, it will kind of install a previous version which will not work as we are explaining it. It's a bit more complicated to run things on that. So if you are using Linux, be sure to download it from here. It would direct you to GitHub page, like these are, so you can have the instruction. You have the instructions also here. So for Mac or Windows, it would give you just an installation file, but for Linux, it's like tar.gz file which you will have to unzip and then install it. So I hope people are following.
They would be. You just have to make an assumption and move on.
Okay, so let me show you and introduce you to Thorny. So when you connect your Pi Pico, it would prompt you to install like the latest version of the firmware. So you can click install, because my Pico is right now connected via USB, and yeah, it's in the boot cell mode because mine has not restarted after the installation, because I already have MicroPython. So I would just cancel right now and stop it. I'll unplug and then replug it in again. So when you are prompted to install the latest firmware, you can just install it so that we are on the latest file. So now we will write our first Python/MicroPython code, which is traditionally hello world. So this is the syntax in Python to print out, as in display information. So we will go print open quotes hello space world. All right. So now to run this, you would be pressing this green button. So it would ask you where you want to save it. So preferably you can save it on the Pico. So now you have to name your file. You can name it hello world, hello_world.py. So the important thing is to not forget this .py at the end, file extension. Otherwise it would get saved as just some kind of a text file. So if you add .py in the end, Pico will know that it's like Python file. So once you save it on your Pico, it would run, and then you would see the output down here that says hello world. So if you want to print out something else, like just replace those words inside the quotes. And then you save it, and then you run it. So here you see this is the output that you are seeing down. So this is your very first Python and MicroPython program that you have run. So congratulations and welcome to the world of programming. So if all of your installation went well and everything is okay, you should have reached so far up until now. So now we'll go back to the deck and then explain some more things before we go into the hands-on.
So now you have set the LED already to glowing state, right?
Yes. So I have set this LED to come on when you power. So you might not see this indication right now. So that's all right. As long as you see the Raspberry Pi appearing as a flash drive kind of a removable disk, you are good to go.
Okay. You want me to bring up the deck again? Okay.
So up until now, we have installed MicroPython. We've installed an IDE. An IDE is a integrated development environment where we can type code, save it, and then run things however we want. So now we will just go a bit into all the components that we are using. So this is a breadboard. So the name breadboard, it has come up because before we see these plastic breadboards, people used to use actual boards of wood where they would nail in and then connect wires around to run circuits and try them out. But now we have this and the name stuck along. So these breadboards, they have holes in them in which you can connect your pins and very easily run a small circuit and all the trials that you need. So I'll just walk you through about the connections in the breadboard so that you're not confused in the hands-on. So you can see that there are 5 holes horizontal and then 2 rails on both of the sides. So this 5 pins are connected like horizontally.
This is what you're saying?
Yeah, you can click
Oh,
like this,
okay.
and then the rails are connected through and through. And this is the same on the left side of the board also. The rails are connected that way, and all of these 5 holes are connected individually like this.
Okay, fine.
So now we have jumper cables. So they are also so there are 3 kinds of jumper cables. There is male, then there's male, female, and then there's female, female. So we should be good if you have male to male and male to female. We don't have much of use for female to female, but it's always good to have. Better to have and not need it than to need it and not have it. So it's better to have all of these. So the jumper cables we will be connecting onto the breadboard. So this is like used for if you don't have a breadboard, you can directly connect the jumper cables to the pins of all the components and then run your circuit. But given that we have a breadboard, it's a lot easier and safer to do. So next we will be using LED diodes. So let me just tell you a small bit on this. So what happens is when you power the when you give current, so the LED diode converts this electricity into light energy, but it does it very efficiently when we compare it to the olden days filament bulbs, which used to give out a lot of heat. LEDs don't do that, so because we don't have that loss, they are very, very efficient. So the thing about LEDs is that they are bipolar. If you look very carefully at the 2 legs, you would see that one leg is longer than the other. The leg that is longer is the anode, as in the positive side of the LED, and the one that is the cathode is the negative side of the LED. So when you want to give power to an LED, you want to give you should be giving power to the anode, and then the cathode or the negative side should be connected to the ground. So only if this is satisfied that the LED will glow. So the pins have to be on they should not be connected to each other. Next we have a buzzer. So it's called a piezoelectric.
Some of these. Take that it's separate. Oh, okay. Fine.
A piezoelectric buzzer, which is just called a buzzer or a sounder or something like that. So how they work is they have metal strips inside them that begin to vibrate at a particular frequency when given current. That is how the buzzer produces sound. They aren't bipolar or anything, so you can just plug them up and they should be good to go and they should be running safely. So now before we go into resistors, let us just understand current a little bit. So resistance is measured in ohms. Ohms is the unit. So ohms will try to restrict the amps. More ohms, higher the ohms, the more the restriction. And volts is just the pressure by which the amps are being pushed. So this diagram kind of gives you a general idea so as to not get confused.
So what's going to be important is in some of the experiments that we are doing, you may need to use a resistor so that you are able to control the amount of current that flows into that component, right? Otherwise, oops. Yeah, are you able to hear me now? So somebody was saying we are not audible. Can one of you say if you are able to hear me?
Yes, sir, very much.
Okay.
Yes, sir, you are audible.
Okay, Showman was mentioning we are not audible. Okay, Showman, you may want to check the connection from your side a little bit. Okay, good, thank you. So, for certain components, you'll have to make sure that you are connecting the resistor so that you are able to control the amount of current that comes to that component. Otherwise, the component may get damaged, right? So there are recommendations on that. When you are connecting an LED for LED we have, right? So for an LED, you will put a, how big, what kind of a resistor will you put?
So 330.
Okay,
They
so we'll
already
see.
ordered for that.
Okay, so you would have already ordered for that, so to make sure that you put the resistor so that the LED does not get
On
affected.
the best day, best case scenario would be that your LED will get damaged. Worst case might be that it might burn your Pico as well. So very important to when you're using.
One second, guys. Okay.
So the resistor.
We already spoke about it. So.
Yeah. So there are some properties of resistors that help us to identify them. So there is the first band, the second band, and the multiplier band, and then the tolerance band. So you identify which resistor you have by identifying the color on each of these bands. So let us have a look. So if you had, like, say, the color 1, and then on the second band you had the color 4, so that would mean you have 14 ohms, and then the multiplier is again yellow, so that would be 14 into 10 to the power 4 ohms, and then the tolerance, say you have green, so the resistor would be plus or minus 5% from this. So you guys can check out what resistors that we had ordered, and if you have it right by referring to this color scaling.
Okay.
So next is the potentiometer. You can think of the potentiometer like the volume control on your TV, like if you can increase or decrease the voltage. So when the potentiometer is connected at just two legs, it can be used as a variable resistor. You can control how much resistance you want for that one particular circuit, and then you can increase it or decrease it by turning the dial that is on top of that. Next is an I2c display. So this is very special because Raspberry Pi Pico interfaces with I2c. So I2c displays are what you need when you're connecting your Pi Pico to have an LED display.
I'm going to do a LED display.
Just for their information. If they're ordering, they need to know it.
Okay.
So now we would come to physical computing, like begin to write code that does things on the Raspberry Pi. So the first program that you would be writing is to power on the onboard LED. So the onboard LED is connected to Rp2040 pin 25. If you had noticed that after 22, the pins skipped and straight up started at 26. So these remaining pins, like the onboard LED, are all connected to these internal the pins internally. So we don't have access to them from the outside. So first you want to load up. You need to load up Thoni, and then configure it to Pico. I will show you how to do that now. And then next we will start coding. So the first line would be to import the machine module. So you can see that the machine library is what enables us to communicate properly with the Raspberry Pi Pico. So this is like the main library of MicroPython. So the machine module allows us to program and control the GPIO pins, and then it kind of exposes an API for you to communicate with the Raspberry Pi Pico. So an API is just an application programmable interface. So it allows you to program the things that are there on your Pi Pico very easily. The name might sound scary, but it's just there to make life easier. So once we import the machine module, we will be declaring a variable called OB-LED. So OB stands for onboard and LED stands for light emitting diode. And we will be declaring it as So the machine module that we imported, it has another module pin inside it. So machine.pin will be calling the pin module from the machine library. So we will be declaring it as 25, which is the port number to which the onboard LED is connected. And then we need to set this pin as an output. So machine.pin.out. Here we are referencing the pin and the pin module from the machine library, and then we are setting it to out. So the case is it's case sensitive. So if you like mix up like small and capital the upper and lowercase letters, you will get a syntax error. So try to keep a note of this. So now
Oops. That's the problem. I have to go all the way back. There is nothing like one step back, is it? Okay.
So first, you would be setting the OB underscore LED dot value. So what you are doing is the declared variable that you had, we are setting a value to it so that we can like control it. So a value of 0 would switch it off, and a value of 1 would turn it on. So if you set the OB LED's value to 1 and then run the code, it should like light up the onboard LED like how you can see it on my Raspberry Pi Pico. So you can then change the value to 0 and then run it again, and then it will switch it off.
Okay. We should go now. What about that?
Are they doing?
No, we'll talk. I'm going to check on the chat. Okay, so we are now Akshay is going to demonstrate from his screen. I'm going to mute from here. He is going to whatever exercise we did now, right? Whatever we showed here, he is going to on the whatever we showed on the screen, right? The code he is going to do it on the Raspberry Pi and demonstrate it. Just hang on 1 second. I'm going to go on mute. Okay, 1 second. While Akshay is setting that up, folks, on the other laptop, I'm on chat. If somebody asks a question, like while Akshay is going to demonstrate this, if somebody has a question, please feel free to ask me on the chat. I will respond to you.
Okay, so first we will be setting up the code to run on the Pi Pico. So how we do that is on the bottom right corner over here, you can see that my Thorny is selected onto MicroPython Raspberry Pi Pico. So yours might have a different value. It might be running the Python that is installed on your system. So you need to change that by clicking on it and then selecting MicroPython Raspberry Pi Pico. So once you select that, your code, you should get kind of message like this. So this means that you're connected through the Pi Pico. So now let us import the machine module.
Folks, the reason why what Akshay told now is important is because on your laptop, you may already have a different version of Python running, right? So depending on what your programming interests are, some of you may already have a different version of Python running. So when you are trying to develop something, that code which has to be deployed on Raspberry Pi Pico, that you will have to choose the appropriate version. So that's the reason it is important. Because using this IDE, you can probably develop some other program, a Python program as well, which will actually execute and give the results on the screen. But it is important for you to choose the right version.
So if you remember that my Pi Pico already had the onboard LED glowing, so I would be stopping it. So now the code is executed, and let me just show you that it has turned off.
Just need to turn in the shadows.
So now, if you can see that the onboard LED is off, now I'll toggle it back to on again.
Leave the shadow of the chapter. Leave the shadows.
So now you can change the value to 1. So this will light it up again. And
Don't forget to unshare. Leave gas. Just turn the camera.
turn the camera. Right. So you also have the option to toggle. So if you toggle it, it would go off, and then you run it again, it would go on. So I can show you this by sharing my screen. Okay. I can just pause sharing. So you can now see my Pi Pico. I'm toggling the onboard LED. So it's off now.
I think you might unshare. Is that comes on.
So now we are using toggle to turn on and off the LED. So now it's toggle down, toggle down, toggle down, toggle down. So you can do it as many times as you please, and then we will get back to more.
I hope we are trying to keep moving fast. We are not able to check if some of you who have the kit with you are able to do that as well. I'm hoping that you are able to ensure. We are doing very simple exercises, so the code is also there on the screen. We are just showing that, and we are keeping on moving. Okay. So the first exercise of using Tony to write a simple 3-line program. Okay, so you have imported the machine. You have set a variable. Basically, you are taking control of a certain pin into a variable. Right? So you are simply declaring that the pin number 25, to which the onboard LED is actually connected, you are using that as an output pin. That is what you are saying there, right? Machine.pin.out. And we are setting, we are giving that status in OB underscore net as a variable. That variable or the object, you are actually setting properties, right? So you are calling toggle as a function, or you are actually setting, you are using the value method to give supply a value of 0 or 1, right? If you supply a value of 0, it switches off. Supply a value of 1, it switches on. If you use the toggle method, it keeps changing. If it is 0, it gives 1. If it is 1, it gives 0. So using this, you are basically controlling the behavior of the onboard LED using the microcontroller. So that is the first exercise that we have done. What is the next one?
Next is the external LED.
We will now connect to the external LED. I'm sharing the deck again. So this is experiment number 2. So in this we are going to okay, I have shared my screen now. So we are going to the second experiment. Remember the, where are we? Okay, there we go. So powering an external LED is the second experiment. Okay. Okay.
So this would be how we need to set it up. So the third pin. The third pin on the right side, that is the ground pin. So we'll be connecting the ground pin onto the right side rails, that is the last rail. So now your entire rail becomes a ground. So any other module except for the LED, if you have anything else and you need to ground it, you can just connect it off to the side rails, and then it will get earthed. So that,
and on the side rail, you have to connect it to the outermost, right? Not the inner one. Does it matter?
You can use
either of them. Okay.
Just because it's labeled minus there, so it's powered like that. It's just convention. If you want to use the other rail, no problem, you can use it. It's just a rail.
So first step that he's saying is you take a jumper wire, right? You take one of your jumper cables, connect. This is the third one. So the way you count is when you look at it from the top, you are basically looking at the third here, right? Pick up, in the place that is shown, like in 24th position from left to right. If you see, it can be other also, but let's take this example. You take the 24th line, on that insert one end of your jumper cable, the other end of it connect it to the first row, if you will, right? So to the right, to the side. So that actually earths it, right? So this creates an earth. So this entire line is getting earthed now, right?
It's the yellow line here in the rails, that is the ground.
Yeah, you speak up. That's when you can straight away say.
So this yellow line over here, this is the earth. So yeah. So and then this is the ground of the Pi Pico. So the third pin on the right side is the ground pin, if you remember. So now your LED, it should be like the longer leg is on the left side of the board, and the shorter leg is on the right side of the board that is connected to the earth. And then this is a very important step, like when you're powering an LED from your Pi Pico, you always want to use a resistor. So the appropriate resistor of which you have seen the ohms referring to that table that I had showed you, you can just connect it out from GP15, which is the last pin on the left side, and another leg towards the positive leg of the LED. So now what is happening is the GB pin 15 is now connected to the positive side of the LED, and then the negative side of the LED is earthed through over here on the third pin on the right side. And then I will show you, once this is complete, once you have this setup, we can then go ahead and start programming. I will just start setting it up right now.
Okay. Do you want to look at the code also? And then we'll move there. Yeah. We'll finish the code also. Okay. So for this external LED, there is an associated code. So the first is the hardware setup, right? So that we completed. So let me repeat it quickly. You are going to take this line number 24 here. You are going to take a jumper cable and connect it to the earth, the ground side here. So this entire line is your ground. So you can pick up from one of these points and connect to the third pin here, which is the right side of the Pico. So put it onto the third on the first column here. Of course, you can put it on the second one also. So this is the second jumper cable that you are using. Then you are placing the positive side of the LED on the left side of the board, the negative on the right side of the Pico, right? So you will have to make sure that it is going onto the, each leg is on the other side, right? And then you are taking a resistor and you are connecting it to one cell on the same line, and you are connecting it to the 29th position here, right? So once you do that, your circuit is complete. Then you can come to the programming part, right? So it's showing the resistor also. So on the coding side, you will again come back to Thorny. On Thorny, there are like 4 or 5 lines. I hate this. Please hang on this. This is a problem with the, okay, I'll leave it like this, guys. So this is the code that you write, right? So similar to the earlier code, you are going to import the machine. You are also going to take the time module. So Akshay was mentioning to me yesterday that the regular time library that you have in Python has been converted to utime library here in MicroPython. So you are importing that also. And then you are declaring another variable LED external, a similar process to what you did for port 25. Now you are doing at port 15, right? So earlier for the onboard LED, you did 25. Now for the external LED, you are putting it at port number 15, right? And you are declaring that that's an output port. Then you are getting into an infinite loop where you are going to toggle the external, right? With a sleep time of 5 seconds, 5 seconds or 5 seconds. So for every 5 seconds, you are going to keep toggling. So that's the code that you have. Okay. So we will now run this experiment on the board. So you will first, I will unmute for you. Sorry.
The important things to note over here is the utime library. So even if you import the time library, MicroPython would use the utime library instead. So for those of you who know Python and who have been working with Python, you know what the time library is. For those of you who don't, utime is just to like delay stuff and things like that. So when you use utime.sleep, in round brackets, you can give how many seconds you want to delay it. So that is what the last line is. And the line above that would be toggling the LED, and the while loop that is there on top of that, while true, is an infinite loop that will keep running the block of code that is there below it over and over again until it stops. So another important thing to note over there is the indentation. So right below the true, there is a gap of 4 spaces or 1 tab, and then the code is beginning again, like led.external.toggle. So toggle will, if the LED is off, it will turn it on. If it's on, it will turn it off. And then it would wait for 5 seconds and then come back to the first line again. So the indented part that is below the while loop would keep running over and over again until it stops. So this is the syntax of the while loop, and rest of the stuff is, it's not very complicated, I hope. And those who don't know Python, I think you can follow along. So now let us do it on Pani, so that
I'm going to stop sharing here and I'm going to unmute.
Okay, so I hope everyone can see my screen. So this was the last program that we were running. So we want to stop it so that I need to plug all of them. Okay. Okay, let us do the wiring. So the third pin is the ground. 1, 2, 3. You put it on the outer rail.
You may have them for 2 seconds. Try to look at it from the screen. From the screen we have.
Right.
You are actually finger streaming across. Yeah.
So the third pin, 1, 2, 3. This is the earth of the Pi Pico. We take a male-to-male jumper cable. This goes on third. This goes on the outer rail.
I would say
So this end of the breadboard would be the negative. If you can see the difference in the legs of the LED, the shorter one is
vertical.
better.
Vertical.
Okay, so the shorter leg is negative or the cathode, and the longer leg is the positive or the anode. So you want the anode to be separated by the cathode and not on the same. They shouldn't be connected to each other. So I'm splitting them like so. One end at this side, and so we were on the third. 1, 2, 3. You plug the. No, this is 15. 1 moment. So this is 15, the last. Uh, so, okay, let's do the earthing first. So now that this cathode is connected onto this edge of the breadboard, all of these connections, as I had shown you in the video, they are now all connected to this leg of the LED. So if you take the connection from here or here or anywhere on this, it doesn't make any difference. It's all the same because they're all connected. So I'm taking it from the end. And then because this jumper is connected to this rail at the very last thing, this entire rail becomes your ground. So you can connect it anywhere on this entire rail and it should earth your LED. So now we are earth. Now next, let us add a resistor.
Folks, we are trying to go as slow as possible so that you are able to follow. Whether you are doing with us or you are going to do it later, we want to be slow. We actually can turn around the board that will be a little more visible.
So the resistors, they don't have this bipolarity. So any leg can go on either side, doesn't make any difference. So, were you able to hear me? Hello?
Yes, sir.
Previously as well?
Yes.
Okay. So, OB LED is the onboard LED. We'll just leave it at on so that we know when our Pi Pico is connected to power. So next, we would declare another variable. This one is on. No, it's off because I toggled it off last time. The LED. Yeah, anyway, it is working. So now that the onboard LED is on, okay, please repeat the resistor part. So the resistor is connected to the GP15 of Raspberry Pi Pico. So when we program this to be an output pin, it would give out voltage, which would give out current in amps, and the amps would get restricted by the resistor, and the remaining amps would be converted into heat energy and lost to the environment. So the reduced current would flow through this leg of the resistor onto the breadboard, and given that all of these are connected, it would come into the LED's anode and then light up the LED, and then this would close our circuit from the negative side, moving on to this pin. So these this is a single connection. It would come over here, and this would move on to the rails, and the rail, which in turn is connected to the Pi Pico's ground. So this completes the circuit. Did you get me this time, or you want me to explain again? All right. So now on to Thorny. So we have set the onboard LED value to be 1. If you can see, there is no indication whether you are connected to whether you're connected to power, or if it's running, or even if the Raspberry Pi is on. The only thing that you can see is that when it comes on board, on your system. So I would recommend that you leave the onboard LED on to know that you are getting power. So now let me declare the other variable. So it would be machine dot pin 15 and machine dot pin dot out. So we are programming the 15th CP pin of the Pi Pico to be an output pin, and next we would be setting this, giving it a value of 1. Okay. Is it better now? Can you hear me?
Yes, sir.
All right. So the same way that we were sharing, we were programming the onboard LED. We are now declaring the variable to be at pin 15 and machine out, and we are setting its value to be 1. So if you run this, you should be able to see your external LED light up. Let me show you mine. So now that we have this external LED pin 15 saved as a variable, we will now go into the infinite loop. While true is the infinite loop that we will define, and it ends with colons. And then when you enter, it would enter into an indented part. So you want the external underscore LED dot toggle. And then we would also need the utime module, utime library. So now we have utime. So utime dot sleep for let us keep a smaller duration, say 3 seconds. So now I stop the code and then rerun it again. So if you can see the onboard LED, it would light up for 3 seconds, then turn off for 3 seconds, and light up again for 3 seconds. And this would keep on happening until I stop the code.
We'll pause there. Okay. Folks, you can actually go a little lower. There is one. Okay, so folks, we are going to take a 5-minute break. It is 11:45. So please take a 5-minute break. I will give a quick summary of what we have done so far, so that we can, once you come back, we can resume. I will also want to ask one person who has been trying to do. I don't know which of you are, I got like 6 or 7 names yesterday. If one of you can say if you were able to follow us, what we are doing. Of course, there will be a recording. You'll be able to replay and try all of these things again. But has anybody attempted so far, and have you been able to do? Can one person respond in chat so that we can or unmute, and can one of you actually talk? I don't know which of you are experimenting now along with us. Raviraj, are you Raviraj or Bajrang, Nengni Them, or any of you trying to do? Manisha Sinha. Oh, okay. So Raviraj, I understand. Is anybody else trying to do this? If not, I would like to know at least if the speed with which we are going and the level of detail that we are sharing, is that good enough? Are you guys able to follow us? Because we are trying to coordinate between a presentation running on my laptop and the code running on Akshay's laptop. So we have a table on which the entire circuitry is laid down. So we are trying to actually manage between these 3 things. So I want to hear from one of you if you are able to follow what we are doing. We are trying to be slow. I saw a note from Raviraj.
Participants kindly respond.
One
That will
person.
give feedback.
Yeah, one person has responded. So Raviraj has said, he's making notes so that he'll be able to perform step by steps. Yeah, we will also share you the presentation, so you will be able to follow that. That also gives you step by step instructions, and like what Akshay was mentioning, by the end of the day, he will actually publish all this code into a GitHub repository from Neoware's GitHub repository, and we will also share it will be a public repository, so we will send out an email to all of you so that you can take the code from there as you are trying to experiment. So both the instructions, we will publish it there. Okay. So I do not see anybody commenting otherwise, saying it is too fast or too slow. So we will probably continue with the same pace, right?
I think the space is okay, sir.
Okay. Fine. So it's 11:48. So we'll probably come back in 4 to 5 minutes. Okay. So we'll resume at 11:55.
Mr. Rajaraman, sir.
Yeah.
Sir, actually, I have some suggestion.
Yes, please go on, Brady.
So actually, the speed-wise, it is okay. There is no issue.
Okay.
But my request is, you take one case study. Say, for example, if a student is going to do a project, say supply chain management. So from Chennai, he is ordering something from Amazon or some other website. Okay. How the Amazon is packing the material and what are the different steps available. Okay. And how they are using IoT in different steps, and how finally it reaches to the customer. You take, this is the case study. It is, I am suggesting, but participants may come with a different idea. You take this case study and just propose a model with the results.
Okay. I think that's a good idea, Prannivel. I think we can do that.
Yes, sir.
Only point is, I think you will need some basics before that. If you are actually trying to replicate or trying to do something similar to that,
yes,
you need some basics. So we will cover that, and probably towards the last session, I will give you a quick run through of how you take any supply chain, right? Now, like what you said, any logistics company, if they are trying to as part of their supply chain, all the way from receiving an order and fulfilling an order, what are the different steps and where IoT is being used, that I can definitely walk you through. You may not be able to implement it today, but we can walk through. It can be an offline project for people. People can come back and ask us questions. We can direct, but because all of what we are doing now will be the basics that will be required for as a first step, right? Because without knowing how to control a port or how to interact with the devices, see, the eventual objective of what we are trying to do today is to give a primer on how to interact with the devices, right? That is the idea, right? So once you know that, then you can build on top of this into a little more complicated cases. So we will speak about that in the last session. I will take 10-15 minutes to just talk about the example that you gave. Okay.
Yes, yes, sir.
So if you are able to see my screen, so this is what we completed now, right? We connected the external LED and we toggled it for every 5 seconds, right? Now, next we will do is a signal, a very similar use case. Only thing is, we are going to connect multiple LEDs here. So if you want to actually show on the camera, are you connecting multiple now? Or then talk through it, right? So you put your screen. So what we are going to do is just an extension of this, folks. Okay. So hang on 1 second, Akshay. So initially we connected one LED and we took a jumper cable and we grounded it. We had one resistor. Now we are going to add 3 LEDs, a red, amber and green. And for each of those lines, we are going to take a jumper cable and ground it. Okay. On the other side, we are also going to put a resistor. So there are going to be 3 resistors connected. And for the resistors that are connected, you are going to take for the 2 other jumper cables, you are going to, for the 2 new resistors that you have connected, you are going to take 2 jumper cables and connect them like this. Right? One of the legs of the resistor, right next to it, you are going to put one end of the jumper. The other end of the jumper goes to the next row. I think that is P14, is it? P14. It goes to P14. Then similarly, the third resistor, you are going to take one jumper and put it right next to that, or basically on the same row you will connect. On the other end of the jumper cable, you are bringing it to P12. P12. So for each of these LEDs, you are going to put a grounding also. So you are connecting a total of 4 jumper wires, which are actually taking it. So these 3 are grounding it. The other one is grounding the Pico board, right? So there are 4 grounding here, and then 2 jumper cables which are connecting to the lines where you have the resistors connected. Then you have 3 LEDs total. Okay, so that is the overall circuit. So Akshay will show it through his camera. I'm going to stop now. So he is doing the connection from his machine. He is going to show that.
So this is not very different from what we did in.
Is your camera on? Video is on, is it? I am tired. Yeah.
So this is not very different from what we did in the beginning.
You don't have a number, isn't it?
We'll have
In both 3?
yeah, 2 greens and 1 white.
Huh?
2 greens and 1.
Yeah.
2 green and 1 white.
Replace that. No, where is the amber? That is red. Oh, okay. We use this then. It becomes a lot more clear because on the screen it is not clear enough. What's this? Green is fine. So you still have the first code only, right? Whatever
Yes.
code earlier.
Still running. So if you want to stop it, you can just unplug it.
Oh, that's okay.
Yeah, that shouldn't be any problem. So as usual, check the legs. Positive comes this side, negative goes that side.
So can this be connected anywhere, or do you have specific places?
They have shown specific places, but anywhere is okay. Shouldn't be a problem as long as you're
wherever you're looking, you need to know the number, right? Or you don't care.
No, that's not it.
Because you're doing based on this.
So it doesn't matter where you plug it on the breadboard, because ultimately the pin where you connect it on the Pi Pico is what will matter. So these are all internally connected like this, and these are connected like this, and these rails are connected sideways. So this is just there to help us do the connection, help us connect things more easily. That's all.
One moment, actually. I just want to share my screen for a moment and talk a little bit about this concept.
Yes, please, sir.
So, folks, if you see the connection here, yeah, if you see the connection, if you see the connection here, there is this output pin. Go to play mode. Okay. So there is this output pin, which is P15. Okay. because this entire line is connected, you are actually connecting a resistor from here. The other end of the resistor is connected here. On the same row, you need to have the LED. Basically, you are connecting, instead of soldering this LED's anode to this end of the this output, you are connecting it using a resistor. So basically, it's like it's roughly equivalent to connecting the LED and the resistor to this. Right? That's what you are accomplishing here. Which is why when Akshay said it doesn't matter where you put the LEDs, all that you have to ensure is one end of the resistor is connected to this, and the other end is in the same row as this. Right? So if you look at the second one, you have put the resistor here, but this end of the resistor is connected to this port, output port of the Pico board using this jumper cable. Same way for this resistor is connected to this port of the Pico board using this jumper cable. The other end of the resistor is connecting it to the diode, to the LED. And then the LED is getting grounded. So the circuit is getting completed through the Raspberry Pi, right? The Pico. So the jumper cable and the resistor, in essence, is equivalent to connecting this LED to this port of the Pico. So it doesn't matter where you put these, so long as the lines are taken care and the jumper cables are placed in the right places where the resistors are connected. Okay. Then you can program this port. You can turn on this port. If you turn on this port, then this port is connected to this green, so this will glow. If you turn on this port, then this is connected to the amber and this amber will glow. That's the essence of it. Okay. So I'm going to mute here.
Yes. So now the previous code is still running. I've just replaced the green LED with red, just so that we are sticking with what we saw on the circuit diagram. So now, if you can see, this LED is connected to this diode, this resistor, and this resistor ends up over here. So now this entire row is part of this resistor from this end of the resistor. So now we will plug the amber light, onto pin 14, which is one above pin 15. Pin 15 is this one where the LED is glowing, which we had used last time. And now the green light to pin 13. So if you remember the diagram of the Pi Pico, after the last two pin 14, 13, there is so this is the port pin. So pin 13 is one above that.
Okay, 1 second. I have a suspicion. See, this one. Oh, okay, you have to pick the next one, right? Okay. So you are in 15, 14, and 13.
So now this entire rail is connected to the ground. It's grounded. So we'll just pin it up from the negative of the cathode of the LED to the rail of this LED. Now the next one. They're all confused.
That is not visible with the screen.
So, so the entire setup once again, but we can do it a bit faster. So pin 15 is connected to this LED via directly this resistor. So pin 14, the red wire is coming over here, and this line of the breadboard is connected to this LED's anode by this resistor. So pin 13 is one after pin 14 because there's a ground in between. So pin 13 is connected same way how this amber light is connected. So pin 14 comes over here, and then through the resistor it goes into the LED, and then the cathode are all grounded on this rail, which is connected to this ground through this white wire. So now we will program it for it to run. So when right now what is happening is Pico is actually busy. It's actually still running the same blinking thing that we had implemented some time ago. So anytime you try to run something or try to open, and then you try to open it on the Raspberry Pi Pico, and then you get this message, it means that it's already executing some code. So you need to stop it. You can look at the console shell down over here. It says that it's running. You can see %run -c editor content. So once you stop it, the shell, these arrow marks would point out to be empty. So now we are ready to write some more code. So let us leave the onboard LED on, and then we would specify red. Let us use red as a variable. Red is equal to machine.pin. So red is connected to pin 15. Pin 15 is now out an output. So next amber is connected to pin 14. And then green is connected to Shri. It's connected to 13. So now red, amber, and green are somewhat similar to the traffic lights. So now let us start an infinite loop. So on the next line, at an indented, after an indentation, let's start lighting up the LEDs and use U time to control them. So first, as usual, let's start from red. So this would turn on the red LED. U time.sleep, 3 seconds. So the red light comes on, and then we wait 3 seconds. Amber.value. Okay. So now after 3 seconds, the amber light would come on. And then after 2 seconds, yeah. So
switching off red. After the amber comes, you're switching off red.
so after the amber comes, after 2 seconds, we'll switch off red and amber. So then the green light comes on, and then the green light would be on for say 3 seconds. So okay, so red light comes on 3 seconds, and then amber light comes on, and then 2 seconds, and then red and amber get off, and then green gets on, and after 3 seconds, again, after 3 seconds, green would have to get off. Yeah. And then the red light would come on again.
That's fine. This is the actually put an amber also here. So that's fine. Okay.
Yeah. Okay.
Folks, hang on. We are actually trying to check what is happening here. Redeploying. Without the sleep, can you actually try to set everything to 1? Let's see. Because I don't think it's it's not the sleep that is causing, but I'm saying other two are not showing at all. Again, what happened?
I think the two things are.
these two. First, okay. On the screen, actually, look at it here. This is red now. Red itself looks like orange. Folks, if you are able to see, I think based on the program that we wrote, for 3 seconds, red is on, and then amber comes along. For 2 seconds together, both the amber and the red are on, and then both of them get switched off. Then green turns on. Green is on for like 3 seconds, then green switches off, immediately the red comes up. 3 seconds on red, and it goes into infinite state. So basically, you are controlling this. For the essence of this is this, right? That when you have these 20 odd ports on each side on the Pi Pico, you are basically programming the Pi Pico board, right? So in any sensor that you connect to, through a breadboard or the folder, etc. So back to the question that finally we have asked, right? So if we are going to use a bunch of devices for us to control a certain outcome, so you have to connect to those to device like this, right? Either a Pi Pico or an Arduino, whatever be that, and then you are going to program through them, right? So that is what you are going to sit down and do. Right? So in the exercise that we are doing today, we are very restricted to this. We will also show you how to read the data, right? This is a scenario where you are treating these ports as output ports. You are also going to see an example of where you are treating these as input ports, right? Where there is a sensor, the temperature sensor and the humidity sensor is going to give those data. It's going to become an input into the Raspberry Pi Pico. From there, you will read it, bring it into Python. Then it's like your data exercise. If you remember, we were saying in the IoT world, each of these sensors are going to give some data, and once that data comes, you are going to land it onto a cloud-based data collection mechanism, and we will perform analytics. So you see the first step of that, right? Where we start putting in, as a time series, every second or every few seconds, we will start collecting temperature information and the humidity information. We will collect that. So you can see that exercise. Right. So we have like 3 or 4 more exercises to be completed. So we will do one sensor exercise. So we'll probably break with another 2 minutes for lunch, and then we will come back. When we come back, we can do first thing that we will do is the sensor, right? So we'll do the temperature and the humidity sensors. We will connect to the same board. We will show how you can read that information. We will probably light up something nearby or come closer to it so that we can alter the temperature with the based on the body temperature. We do that. And so that is one exercise. Right after that, we will also do an analog to digital world, right? So we will connect a 4-way relay switch to it, and then show how to make an AC bulb to blow, etc. Then finally, we will try to connect using a Bluetooth, right? So we will try to do a Bluetooth connection and see if we can program, give some instructions through Bluetooth, right? So there is a mobile app. So I'm sure you will show how to quickly build a mobile app. There are some mechanisms that are available. So you can do a small mobile app where you give an instruction by pressing a button, right? So you can say on off switch from the mobile. That sends an instruction to the Bluetooth module. The Bluetooth module that impacts with the Raspberry Pi Pico, right? So you will look at that actually. So those are the 3 exercises that we will do when we come back post lunch. Okay. So and then after that we will talk about the example that Prandy mentioned about. So what are the different things that are involved in the actual exercise, right? So and I will also try to give you some information about a few other little more complicated IoT projects For those of you who have bought the toolkits, you can try and do the experimentation yourself. You can try and keep going up the complexity
on the input side, right? So
finally arrive at
the
what
lunch session, the
Okay.
2 or 3 use cases
So
that
we'll
we
break them for
implemented were all how to utilize the Raspberry Pi Pico ports. So all the ports, the 40 ports that are roughly around 40 ports that we spoke about, can be used for both input and output. So whatever we did so far has been like an output port, right? So where you are sending out a signal from Raspberry Pi into external devices such as your LEDs, and we have made them work. So now we will go on to the input side. Actually, the buzzer we did not do, right? If we have time, we will probably do the buzzer so that we know the audio also. So we will probably do the input side now. So Akshay has actually brought a temperature and humidity sensor. So he will first show the circuitry on how to connect it. Where do we connect and what is the completion for the circuit. And then after that, he will show the program for you to read the temperature and humidity and write it onto a file or whatever, right? Or we'll display it on the screen. Over to you, Akshay. Yes. Okay, finish. Okay, sure. Should I go to the next topic? Yeah.
So the sensor we will be using today is a DHT22 humidity and temperature sensor. So let's look into it. Okay. So there are two types of DHT sensors. One is DHT11 and the second one is DHT22. So voltage and MA max, all of maximum current, all of them are the same. The humidity range, you can see there is a vast difference that DHT11 is between 20 to 80% and there's a variation of 5%, but 22 is 0 to 100% and variation is 2 to 5%. So there's a vast temperature difference as well. So 0 to 50 and that goes from minus 40 to 80 degrees. So the sampling rate is where the DHT11 takes over. So it reads at 1 hertz. So that means one reading every 1 second. Whereas the DHT22, it gets a huge hit over here and samples only at 0.5 hertz. So that means we would get a reading only every 2 seconds. So apart from that, the DHT11 is is a little bit smaller compared to the DHT22, and it is very low cost. So these are the pros and cons of both of the sensors. And also another point that is not mentioned here is that DHT22 sensors would not round off the value. We would get temperature and humidity up to 1 decimal place, whereas the DHT11 has only round off figures when it comes to both of these.
One second before we move on. So one key point, folks, right? So earlier, Payanivel also asked a question to the related to the practical implications, right? So now if you are actually building an IoT application for a certain purpose, you'll have to choose the sensor based on the application, right? So for example, if you are using or if you are building a home improvement system or a home automation system, then maybe a DHT22 sensor is good, right? So it will be fairly accurate. So you are going to get, for example, you will know the sensitivity of the sensor is that it's giving you up to 1 decimal, right? So the variation is going to be between 23.1 degrees and 23.2. It is still going to show you the difference in reading. Now, this may be good enough for a certain type of applications. So if you see the range here, if you look at the humidity, 0 to 100% it gives, but at an error rate of 2 to 5%, whereas the DHT11 is at a 5%, right? So it can, you will have to always account for a 5% plus or minus variation there. Now, this may not be great for one of the use cases that we spoke about in the last 4 days, right? The ultra low temperature freezer that we spoke about, where even a 0.1 degree fluctuation in temperature is going to result in some damage to the specimens which are being maintained, right? So I spoke to you about the Thermo Fisher example. So there, the devices had to be monitored for even a 1 decimal, right? 1/10 of the temperature, 1/10 of the degree variation had to be spotted. So if there are specific requirements like that, you will have to go into a manufacturing of the chip only, right? Maybe you get some ready-made chips which give you an ability to measure temperatures at that level of sensitivity. If you do not, you will have to go for a manufacturer. That's what a lot of people do, right? So for the purposes of, back to Panivel's question, right? Depending on a certain business problem, you may be able to use a commercially available, off the shelf. You can go and buy it from either Amazon or from one of the electronic stores near you. You could go and buy. There will be some problems for which you will find sensors like that, but there will be other problems for which you will have to talk to a semiconductor manufacturing organization to ask them to design and manufacture a sensor that you need, right? So there are going to be decisions like that, right? Depending, particularly if there are people on this call who want to be entrepreneurs, you are going to face decisions like that depending on what you want to build.
So we can have a look at how it works. So there are two electrodes, and there is a moisture holding substrate in the middle that is sandwiched between these two electrodes. So what happens is when this is the humidity sensor. So when the humidity increases, there is a drop in resistance in the substrate that causes more current to flow through these electrodes. So that is how the humidity sensor works. So more humidity, lesser resistance. So it will give out more current. So that rate is actually calculated and converted into the humidity. So after this, we have a thermistor that is being used to record the temperature. So this is an Ntc thermistor, and Ntc stands for negative temperature constant thermistor. So what will happen is when the temperature drops, when there is a drop in temperature, the resistance will go up. So there will be a very drastic change in the resistance. For even 1 degree, there might be almost 10 ohms or close to that. So that is how the temperature is monitored. So this thermistor is inside the DST22. So now we'll just look at the wiring. So the catch is that DHT22 does not have any pre-built drivers for MicroPython. So we have sourced this driver especially so that for this class. So it will be available at our GitHub. So if you should need to use the temperature sensor DHT22 until the official MicroPython library comes up with a driver, you can of course use ours. So what will happen is when there is a current flow, it will actually calculate it and then convert it into your temperature and give it to us from this thermistor and those sandwiched electrodes. So there are two kinds of DHT22s. So one of them comes with 4 pins like the one in this drawing. The one that I have is of 3 pins. There isn't much of difference between the two. You can see that there is one pin that is not being used at all. So the wiring would be the same. The positive side would have to go to the
So this pin is not being used,
yes,
right?
it won't be used. Okay. And if we are using the 4 pin, we would also need to use a resistor. But for the 3 pin, we don't need. So depending on your, if that's okay with you, you can just straight up try to go for the 3 pin one so that it's lesser hassles. So the negative side of the DST22 would go to the earth, and the positive side of the DST22 would go to power, and then the data would be connected to again GP15, which is already ready for receiving inputs through it's a general purpose pin, so it can receive inputs as well. So the idea would be to take the input and just read out the temperature and the humidity, because those are the values that would come out after being processed by the drivers. So we just wire this right now.
Okay, I'm going to mute from here and let Akshay's system take over.
If you can see closely, hello. So this is the DHT22 3-pin temperature and humidity sensor. If you look closely, you can see that there is a positive, there's an out, and there's a negative. So the positive would have to be connected to the current. The out would be from where the data comes out, and the negative needs to be earthed.
Is it marked there? Can you show this writing there?
Can it be seen?
You see, it's not. There's a positive out and negative. Okay.
So now we plug it onto the breadboard. And the negative to the earth, sorry, the ground, and then the positive over to the power line, and then the out to go over to GP15.
You may want to turn around and show. With the camera, so you can see on. Yeah. So the one on the left-hand side is the positive. The one in the middle, so the orange wire is the data, and the one which is white is the negative.
Yes, sir. So this is how it needs to be wired. So we can just plug this for now.
This is a very simple wire. Only three things to be.
Yes. So, right. So now we go over to Tommy. Let's stop what is already running and open a file on the Pico. So these are the driver files that are custom created right now for Python, for MicroPython. So these files will be available on GitHub. So what you need to do is, let me open one and show you. So like they're all programmed for pin 15. So the DST sensor is connected to pin 15, which is being used as an input. So, and it's also being used as a pull-up. So a pull-up is like, it's an inbuilt resistor in the Raspberry Pi Pico. So like if you are using a button, it would decide that when you press the button, is it on, or when you leave it unpressed, is it on? So that kind of a thing is what a pull-up is. So, okay, so now let us go ahead with the
How would they install the drivers?
So what happens is, Raju,
Is it the same way as the microcontroller installation?
yeah, there is no need to like you can see these Python files here. Now previously, like how we were importing machine is an inbuilt module from Python. So instead of doing that, we will import DHT22, which is this file, as DHT. So what will happen is DHT would come over to our to our Pi file, and then we can run it like how we run the machine command.
Okay. Just like you download main what you download for initially for the microPython you download and position it in the Pico's memory itself. Similar to that, you have to download this system.
Yes.
Or you copy it into the device.
Yes. If you have the Pi file,
That's all. Give the instructions to them accordingly, so that when they try to explain it's not there.
right. So these files will be on the separate folder in our GitHub repository that points and kind of explains about temperature. So you can make out from that. So in that you can have, you will have this DHT11, DHT22 and DHT11 test, DHT22 Pi and DHT22 test.py. So if you are using DHT22, you need to import DHT22 as DHT. Same if you are using DHT11, you will import DHT11 instead of this. So after this, now we see that we just point towards the pin. We saw in the code that pin 15 is being used as an input and as a pull-up. And then, so now all we have to do is, we would, we are creating an infinite loop as usual. And then on an indented block of code below that, we create a variable called sensor that uses this DHT module and then DHT22, and then we point the pin towards that. So we are going to use pin 15 in our to take the input of the sensor. So we will get a continuous print of the reading from the sensor. So we'll just run this for now to see what happens.
We're just checking the circuit is amount of it.
Okay.
The last one had a problem. The last row, ground row and
Yeah. No. What has happened is I've not given power, or I've not and so I've just connected to the rails, but I haven't taken power or so the sensor is not getting power. That's why it's coming as null right now. Let me just share and show you what is happening. So if you can see here, we have connected the positive end of the negative end is the white one. So the negative one is on the rails, and the positive one is this brown color wire. It's on the rails, but the rails are not connected to the Pi Pico's actual earth and the current supply. So it's just we have to make this wiring so that it will get power. So let me just make that right now.
There are some sensors which require power, some sensors which will be passive.
No, all of them would require power. So now we have given power. Now we will earth it. And we'll stop what was running, what is still running is already stopped, and is
The code for some reason you're using pin 4, where T.
pin 4.
Example. Hey, folks, Akshay is actually trying to quickly debug this. He's trying to find out if there is a right pin that we are using. Okay, hang on for one moment, please.
Yeah. So what had happened was I accidentally powered it from the 5 volts instead of the 3 volts. So I was looking up the drawing to make sure. So if we can see over here, now we're printing the values continuously without. Yeah. Okay. Hello. Yeah. So what had happened was I had accidentally connected it to the 5 volt instead of the 3. So now I just checked the drawing once again and I replaced it. Now we're back to 3 volts. So now the sensor, you can see we are continuous. We are printing data continuous. No, there's no gap. There's no sleep. There's nothing. So if you remember from our previous discussion about DST22, it would sample once only every 2 seconds. So because of that, as and when it samples, it's giving out the readings. So
and 1 second, you'll have to unshare your screen and then show the circuit box.
right.
Whatever change you make, show it.
So the white wire, which was as usual ground, is connected to the Pico's ground, which is the 3rd pin. And the 4th and the 5th pin is the 3 volt out. So that is connected to the positive side. And the data is as usual connected to pin 15.
Okay. The white wire, instead of grounding it, you have actually grounded it to the Pico.
Yes.
And then that is one difference. The second one is earlier the power you had given it
Yes. Through the rails, but now I'm giving through the side this entire
oh yeah, okay.
stretch.
Yeah.
Yeah.
But you are taking it through the 3v3.
Yes. And I had connected it to the 5 volt. We actually need 3 volts for this sensor, not 5.
Can you also show the diagram on the screen for more? Can you show that? I mean, you can only show it from the device itself. It'll be big.
Of Pico.
Yeah. That's good. Big one.
So if you look close, so
37. So the number 37 that is being shown there.
now we are connected to 36.
Sorry, 36. 3v3 out.
Yes. Now we are connected to 36. We were previously connected to 39. And the ground is connected at 38.
So instead of putting it on the ground in the breadboard, you have connected it to the ground in the
Yes. Yes, directly connected to Pico because now, say like the example where we were using multiple LEDs, so we have to ground all of the LEDs to the Pico.
Right.
So instead of using each one of them to ground here, we would connect them to the rails. So here, if I am using the rails, I'll be using another extra set of jumper wires that go from here to here and here to here, and then from here to here and here to here. So now we are just directly connected. It doesn't actually make a difference. If we want, we can power it from the rails also. So
come back to the code and probably show it the delay of
so now let me stop. Okay, so all we need to do is add a delay, import U time as usual. U time dot sleep 2 seconds.
So 29.6 is the temperature and 77.0 is the
Humidity right now where we are.
So because we are sitting in a controlled environment, there is hardly any change, right? So humidity also best it is changing the 0.2, 0.3. So if you could you go closer and
Yes.
slower to show?
So I will blow onto the sensor now so that the water vapor from my breath will increase the humidity, and the temperature. So I'm starting now.
Temperature has now gone up to 30.7, 30.2, 30.7. And the humidity has increased all the way up to 99%. Earlier, if you remember, it was at around 70 or
Yes.
so now it has gone up to 99.9%. So now you have stopped it.
Now
You
I've
have stopped going into that, so it will slowly drop now, right?
Yes.
You see that the temperature is coming down to 30.1, 29.9, and the humidity has dropped to from 93 to 89, 84, 82, 80. So humidity is dropping more rapidly. The temperature was like, it did not increase a lot to that. Okay. It's down to 78.8. Finally, come on, sentiment type model, like 78. 78.8 seems to be good. So, folks, one of the practical ways to try and do this, right? So I'm going to pull a very fast one on Akshay and ask him if he can do that now. So we actually skipped the one use case for want of time because to create a buzzer. Now, since we are reading this, I don't know if we can pause now. If we can pause and find out if the temperature, if the temperature crosses beyond 30, it will make a buzzer sound. So
Yes.
that's a very practical way. So you can see that if there is a temperature increase or a temperature fall, then you could actually make the buzzer make a sound. Right? So we could do that. If we do that, then that's a very practical way in which you are using IoT technique for you to raise an alarm. Right? So and you say that the temperature is increasing or the temperature is increasing. So let's see, we'll probably spend like 5 minutes to see if we can do that. So we're going to try and split the values that are coming from there. And we can try to check if we can check for the condition and bring up the port for the buzzer. We can do that. Right? So this was not what we prepared it is. I'm just trying to pull a fast one and putting actually in spot to see if we can do that.
So what we have done here is we are using multiple assignments. It's a small trick in Python where you can give. Now we know for sure that the sensor is giving us two different readings. One is temperature and the other one is humidity. We can see from the previously printed messages that the first one is temperature and second one is humidity. So we can just assign multiple variables to it directly, and then the values would, the first one would automatically go to temperature and the second one would automatically come on to humidity. So now instead of printing sensor.read, we are now printing the separate values. So we can add some text to it to tell us what is what. Yes, it's not working. I think this thing it doesn't work here. So let me just do it the old-fashioned way. Missing something. So now we are saving them. Now we have the temperature in a variable temp, and humidity in a variable humid. So now we have to write a loop if temperature goes greater than 30.0. For now, I'm just printing alert. After this, we'll just make sure that it works, and then we will wire the buzzer in. So it has to come greater than 30 because that is our condition. It's greater than and equal to. Then if it's at 30 also, it will alert. So now let me get the buzzer. It's yeah. Screen. Yeah. Okay. So this is the buzzer.
Yeah, Ravi, that is what he is doing. So he's going to actually bring the buzzer into the circuit.
So the buzzer already has pins, and you can see that there's one longer than the other, which is the same as the LED. So the longer one is positive, and the shorter one is negative. So we are going with the red color on the positive, and sorry, and a brown color on the negative. So this, since we are connecting to pins, we are using female to male jumper pins. So okay. So 1 second. Let me just fast forward the drawing. Okay. So let us use pin 18 as the earth. So 1, 2, 1, 2, 3. So this is the ground. And then we would just connect this over to which pin? Anything is okay. 16, I think 13 is good. So right next to it, I'm using GP13 as the positive, and the earthing below that for grounding. So the buzzer it's just hanging.
Yeah. You'll notice that there are two which are connected, right next to each other, right? One is GP13 and the other one is the ground right below that, right? It should be like, yeah, right next to that. So if you remember the diagram from the morning, let us show the diagram for a moment. So diagram, if you remember the diagram, it's like 17 and 18. I'm going to show you that. So if you see the GP13 there, which is pin number 17, and then
ground, which is right below that, which is pin number 18, he has used those two.
GP13. So now that the wiring is done, let us come over to let us define the buzzer. Buzzer is equal to pin 13 Shri. So
in addition to displaying value or giving alert, you are also
yes. So since we are writing loops. So this is the syntax for a loop. So if this is an if loop, so if and then followed by the condition and then two colons, and on the next line in an indented block of code, we do what we need to do is the temperature rises. So we print alert and then we print buzzer dot value 1. So when we give buzzer dot value 1, so the buzzer will be powered. So since we are telling Pico what to do if the temperature is more than 30. So the else statement, it will do it will run when the temperature is not greater than 30. So
yeah, you can use it. Maybe just reset the buzzer value.
yeah.
Update now. So we may have to we may be able to hear. Folks, I don't know if you heard when it started itself, it went beyond 30, so it actually created a kind of glitch sound.
I need to enter that frequency if you want for it to be louder.
So it's just going to make the frequency to be a little louder. EPS can do it also.
I'll just show you one second. So instead of using value 1, we will use the 16. So since we are using pin 15 over here, where have I defined input pin and input W and So PWM stands for pulse width modulation. So what we will do is, instead of using it as a pin, we will use it as after defining it as a pin, we will also use it as a pulse width. So all this. I think it should work. Okay, so let me increase the temperature. Can I use 29?
No, it's not about the temperature. I mean, there's not enough. What is the unit?
So it's between 0 and 1000. So when it is 0, it will be. Oh, so we have not done the frequency. Buzzer dot frequency of 1000. Yes. Am I unmuted?
Earlier sound was more out of match. Folks are, if anybody able to hear the sound, it's actually making the buzzer is making a sound. So anyways, see, okay, I don't know how many of you are able to hear. You have to put it near the microphone. Are you on mute? Okay. So folks, we can actually hear it. Yeah, so the idea was to try and demonstrate to you, how in a practical context this will apply. Right? So where you are actually interfacing with multiple devices, right? So you are actually taking an input from the temperature and the humidity sensor, and then evaluating the value that was returned by the sensor, and based on that you are taking another action where you are now interfacing with a different sensor, right? So a practical application that we wanted to demonstrate. So I think we did that into the we will continue. We have okay, so I would like you to finish the next experiment in another 15 minutes or so. So we have 17 minutes. By 3 o'clock, we would like to wrap up the relay. So when we bring up here, we bring up the okay. So what we are going to do, folks, just minimize there, Akshay. Sorry, it doesn't happen. So I'm going to bring up the screen here. So this is a home automation example that he has brought up, that Akshay has brought up. So this is the last experiment for the session, folks, right? After this, we will talk about the example that Pioneer asked for. So we will speak about that for some 10 minutes or so. And then I have a poll at the end, and with that, we will wrap up the session. So see, we wanted to gradually increase the complexity of what we are trying to do. Okay. So if you recall back, we initially only powered up the Pico board, and then we did a very simple case of making the onboard LED glow. Then we connected an external LED and then gave a signal for it to glow. Then we made it a little more complicated, where we put a signal with red, amber, and green as 3 LEDs.
and then we went through a little bit of loop and gave the signal for it to glow. So just to demonstrate the processing and the practical application. Then after that, we did the next step, right? So when we came back from the break, we then did the sensor. So we first took the sensor reading, just displayed the sensor. So we shifted from output from Pico to external devices. From there, we came into input. Then after finishing the displaying of temperature and humidity, we actually did the next step of interfacing with a different device and then giving a buzzer sound. Now comes a home automation example, right? So we are going to show a 4-way relay switch, right? So this is only to again demonstrate the level of complexity that you can do, right? So Akshay has 4 analog bulbs with him, right? So this is again an interface. Number one, it's a relay. It's like one simple step towards controlling a lot of lights or fans and switches that you have through a device, right? Second thing is it is also a use case which actually combines analog with digital, because you are going to use the digital as the controller, which is your Pico board and the Pico chip and the breadboard circuit. And you are actually trying to control the analog world, which is your light switches and fan switches. So he's going to take light as an example and show how to control 4 different lights. Okay. And as a next step, we will try to take it to Bluetooth, but there is an issue with the Bluetooth module that we have, right? So we also ordered. So the Bluetooth module does not seem to be communicating properly with the Pico. So we may not be able to demonstrate that part, but we will go through the home automation system in any case. Okay. So go on. So you want to talk through something here?
So the 4-channel relay is actually a device that can switch on and switch off whichever device that we want out of the 4. So right here, each of the 4 bulbs are connected to one part of the relay, and the other one is connected directly to the AC outlet, while the one end of the 4-channel relay, all of them are directly connected to the direct AC power. So what would happen is, so whichever module, whichever of the 4 channels we want to activate, we will send that message through Bluetooth from an Android phone, from an app that we will create on an Android phone. So it would be receiving a string. So based on that string, you would write a condition that would turn on and off the bulbs using this 4-channel relay. So for this, the wiring and everything is written over there. So here we are using HC05. HC05 is the Bluetooth module that we all have ordered. So HC05 requires 5 volts. So HC05 5 volts will be connected to Pico 5 volts, and HC05 ground to ground, and TX of HC05 would have to go to GP1, and RX of HC05 would have to go to GP0. So GP0 is the default UART interface for the Raspberry Pi Pico. So GP0 is TX for Pi Pico, and GP1 is RX of Pi Pico. So what will happen is we have to interchange the connections. Like TX means the Bluetooth module will send that information that is coming by Bluetooth to GP01. So if GP01 is a TX, both of them are transmitting. So TX will have to connect to RX, and RX will have to connect to TX. Like how we had discussed about DHT22 temperature and humidity sensor, there is also another HC06 Bluetooth module. So the difference between this and that is that HC06 can only receive information. It cannot transmit. So that is why I had asked us to buy HC05 so that in the future, if you get some, if you are able to make sense from our presentation, you can of course try out to send messages from the Pi through Bluetooth to various devices to your phone. Or the thing about Pi Pico is that it does not have an inbuilt Wi-Fi to it. So we might need to interface it through devices like this through Bluetooth to transfer data onto another system that is connected to the internet and that can push the data from Pico through Bluetooth through the other device through the internet. So there are not yet any, there aren't any Wi-Fi modules that are currently compatible with the Pi Pico. The Bluetooth modules are also a bit shaky at the moment. So they were working, suddenly they're not working. So that happens because it's like a very, very new chip. So it would take some time for the things to settle. But nevertheless, let us connect all of these. Let us give the wiring, and then I'll show you how to build the app just to send just to send information from Bluetooth from the app to Pico so that you can control things and how everything is working. We can just try it out. Right. Okay.
Show the wiring from there. Yeah, we could probably get started with the wiring. So folks, Akshay is going to get started with showing the wiring, and then we will finish the relay part. We will see how far we can get, right? So I want to retain like 10 minutes towards the end to complete our last use case that we spoke about.
Hello. Am I audible? All right. So you saw the wiring diagram which was in the presentation. So I have done a little bit of it by myself so as to save some time. Sorry, broken. Yeah, no problem.
No, this is 7, is it?
Yes, 7 plus. So this is the 4-channel relay module. This is the 4-channel relay module. So over here, this is the wire that goes from. So you can see alternating wires are connected together like this, and from here to this one, and from this one and to this one. So this one would go to the plug.
You need to go a little more to the left, so that it's. I'm going to step back. Maybe you can step back.
So yeah. Okay. So alternating are connected to the bulbs. So these greens are going directly to the bulb, like here. Oops. This wire comes directly to this bulb. So this goes over to the next negative, and this positive is going directly to the bulb. And on the next one, this is going directly to the bulb, whereas these are plugged together, and this is going into the plug. And from the bulb, the other end, they are all connected together, and this yellow line, it goes into the AC current plug. So now what will happen is the interface that needs to be created over here is between these pins and the Pi Pico. So just like how we were controlling LEDs, we can control these by the GPIO pins by giving it the value 1, 0 toggle and everything. So if you look very closely here, you can see how it is supposed to be wired. So there's a ground, there's an in 1, in 2, in 3, in 4, and then a VCC. Yeah. So there's a ground in 1, in 2, in 3, in 4, and then a VCC. So the VCC is the power where power is supposed to go to the relay module. So in 1, in 2, in 3, and in 4 are connected to the GPIO pins of the Pi Pico, and then the ground is as usual connected to the earthing. So this is what has already been done. So now if we plug this to AC power, we will get the current, and all the lights will glow at the moment until we tell it otherwise, like from the Pi Pico or through Bluetooth. So now let us make a connection. Let us connect the Pi Pico with the relay module. So there is nothing that is very specific to this. You can just wire away, provided that you know which pins that you're connecting to, so that you can access those pins from the Pico. Okay, so the 4-channel relay module. So the 4-channel relay module would require female jumper pins, whereas the breadboard would require male jumper pins. So we use female to male jumper pins to power all of them. Okay, so far what we've done is we've just connected 6 female to male jumper pins to the relay module. So now we will power the VCC. VCC would require 5 volts. So would be connected straight up to the first pin, that is the that is getting powered from the USB, from the micro USB, and before going to the SMPS. So next one, first we have connected the power. Now we will have to earth it. So the ground we will give it to, I think, the third one.
Third or second? Third one.
One moment. Let's drawing. Yeah, third one is earth. So 1, 2, 3. So now it has power. Now it's also earthed. So now all that is left to do is decide which pins you want to connect over. So let us do in 1 to pin 1, GP1, and then into 2. Okay, so after GP1 there's a ground, so you skip 1 and then over there, and then in 3 to GP3. So I haven't exactly followed what was shown on the PPT. You get there has to be no hard and fast rules about GP pins, because you could power. Basically, you want to have the voltage right and where it has to go, and that's it. So you can make sure like what voltage it needs. If it needs 5 volts, you can power it from 5 volts. If it's 3.3, we take it out from the 3.3. So that is the important thing, and it has to be earthed correctly. So now we have the relay module connected to the Pi Pico. So now let us power it up and remember which pins we have used. We have used 1 through 4.
In the relay module, all 4 of them.
So now let us switch over to Tony. And then create a new file. So this is the syntax for writing comments in Python. You just put a hash, and then leave a space, or the space is not even necessary. You can just write hash and then whatever comment you want to write. So all of yeah. So okay. So import machine. And okay, SSD machine. So relay 1 is equal to machine dot pin 1, machine dot pin dot out. So it's not a good practice to copy and paste code, but in interest of time, no, we have not connected the Bluetooth yet. So relay 3 is connected to pin 3. Relay 4 is connected to this. So now, if we give it values 0 to 1, like same how we powered LEDs, yeah, we can just see the relay module first. Relay.py. So let me put it in a loop so that you can see it. Okay, so what we are doing is we are giving relay 1 the value 1 and then waiting for 2 seconds and relay 1 value 0 and giving value 1 to relay 2 and then waiting for another 2 seconds and then relay 2 becomes 0 and then relay 3 becomes 1 and then we wait for another 2 seconds. Relay 3 becomes 0 and then relay 4 becomes 1 and then we wait another second. And since this is an infinite loop, it would keep on repeating itself over and over again. So let me switch over to camera and then run this. Import UI. Confusing.
Okay. Actually, what I want you to do is to just take 3-4 minutes to explain the Bluetooth module and then just the app, right? App and the Bluetooth. Just show the device. Okay. And then with that we'll wrap up because I need to go to the next. So, folks, what Akshay was showing is the ability to do the relay, right? So we are not going into the bulbs. So the core part is the interfacing, right? So we are doing that. The next step is to actually connect to the AC and you can actually show that the bulbs also glow, right? Which is not a difficult part. So we want to actually get this part to show it, coded and shown to you because this is the more difficult part. Okay. So this is another example of trying to interface between a digital and an analog world. That is one. And then next, for a few minutes, Akshay will show the Bluetooth module and the resources for developing a mobile application, right? So once you develop a mobile app, from the mobile app, you can pair to the Bluetooth. The Bluetooth will be connected to the Pi Pico. And then the Bluetooth module will interact with the Pi Pico in giving inputs, right? So that is how mobile apps are being built, right? So today, when we go to the next use case that we will describe, we will show how mobile app and how Bluetooth is being used as a protocol. If you recall back all of what we have been studying in the last 3 to 4 days, you would realize that there is a device or a sensor. From the sensor, we said that there will be a communication. The communication can be through a lot of protocols. It can be Bluetooth or Wi-Fi or Z-Wave, Zigbee, a lot of those protocols we saw.
So through that, the communication happens and the data gets fetched into cloud. And then after that, there is analytics that can happen, right? So we covered the devices part. I just want to show you the communication part also with Bluetooth. We'll spend like 3-4 minutes on that. That will become inputs for you guys to try and experiment something on your own. Okay. And at a later point in time, we will also publish on the same repository the code that is required for you to control this output from the mobile app. Okay, we will publish that also. So Akshay will talk to you for like 2-3 minutes on the modules.
So this is the HC05 desktop. Okay. So this is the HC05 Bluetooth module. So as I had mentioned before, it has the ability to work as a master and a slave, as in it can transmit and it can receive. Whereas the HC06, it can only receive, but it cannot transmit. So to switch it between the transmission and the reception mode, you have to hold this button and then plug it into power. So it's a little bit difficult task to do. So if you do that, it would be only in the receiving mode. So if you plug it in, it would be only in the transmitting mode. If you hold the button and then power it. If you directly power it, it would receive. So this is the HC05 module. And if you look behind this, you can see the voltage and the TX, RX pins and everything that is there. So what would happen is we would have this on our fire it up. So VCC is 3.6 to 6 volts. So we can give it 5 volts of power. So VCC is this pin. So this goes over to 5 volt of Pico. And then so that was power. Now we ground it. So if you can see that it's written ground is a pin next to VCC. So we refer to the diagram. Okay, so 1, 2. So this is the ground. Yeah, third pin. So now there is power. Power is coming to the Bluetooth. So to make it easier, you can just plug it this way. Then you could like see what pin is what. So VCC has come this side. So this goes to VCC. Okay. This goes to ground, green color. Black goes to VCC and green comes to ground. So now we have to just use the TX, RX pins. So RX, GP0 is RX. So we will connect TX to RX. GP0 and then we will power RX, we will connect RX to TX. So this is the RX of the Bluetooth module, and it would go over to TX. So brown color is RX, brown color is going to GP0, that is TX, and then GP1 is RX, which is blue color, is coming to TX of the Bluetooth module. So now let me show you a very simple interface that is present, that with which you can easily build these apps. Let me unpower the Pico. So
So, Professor, we are 15 minutes. I will try to wrap up right as soon as this experiment is done. We will try to wrap up as soon as possible.
So you visit creatorcordular.io. This is the website where we will be making the app. They offer a very simple and easy interface to build apps. So you just need to log in. So let's Google some verification. And then you accept PNC terms and conditions. Okay, so now let's go. So you go to create project, give the project a name, auto. So now you need to have the cordular companion on your installed on your Android phone. So then what you do is test connect to champion, and then the champion has an interface where you can scan the QR code. So once you scan the QR code, it will make a connection via the internet to your phone, and then it will show you uh, real time. So you can keep your phone open and then you can see what all is happening. So first, what we need to do is add a list. Yeah, so we will be adding a drop down list. So if you minimize the app, you will get closed. Yeah, so here on user interface, you have a list picker. It's just drag and drop. So you drag the list picker and then drop it over here, and you can change what text is in it. So we will give this a Bluetooth icon. You can give it a name Bluetooth, and then string. Okay. The font size. Okay, so the typeface. So if you do that, you can like see the icon. You can use 50. It's a bit bigger. So I'm just rushing through things. So we add list picker tool. We go into layout and in general.
Sir, you can finish your work, sir. How long it will take?
Professor, we
Yeah.
can wrap it up in like 5 minutes, Professor.
Okay.
Folks, as Akshay was demonstrating, right? You could actually build a mobile application like this. So after the there is a keypad and the C from that. Can you minimize the sound? Yeah. So after the after the Bluetooth module has been connected onto the breadboard and you have interfaced, you can actually build a mobile application like this. And because mobile has Bluetooth and you have put a Bluetooth module on the breadboard connected to the Raspberry Pi, you can communicate to that through Bluetooth. Okay. So any application that you build here, you can send out signals. Only thing is you have to think through in terms of not just application, but in terms of what type of signals have to be given for you to pick up information from there. So one simple program that you could write is, after you do this interface, you can actually write a small mobile application where you connect the same sensors, right? The temperature and humidity sensors. You are getting the data from there. You can push that data back into the mobile application. You can create a display here. Similarly, you can also say, you can make a buzzer sound there or take that noise and bring it back into the mobile. You can send out mobile alerts, right? So instead of making the alerts on the board, once you detect what is the temperature that is coming, you can send out mobile alerts. That's how a real world application is being built. We wanted to give you a taste of that because we are running short on time. We will pause this here. We will send out, if you look at our GitHub, we will publish a document where we will give you some additional information about how to build this application so that you can do. So you'll have to stop the sharing. So you'll be able to get some additional information about how to build this yourself. Okay. Because we have not completed this exercise, we will try to do that offline. Okay. We'll give you that information. 5 more minutes. I will quickly run through the question that Panivel asked. So in the lunch break, I actually put together a very short slide deck. If you were to do an integrated supply chain dashboard, how can you do that, right? So, and how to improve the objective of an integrated supply chain dashboard will be how to improve the efficiency of fulfilling the orders, what type of devices you can use, and how does the overall assembly line look like. So one simple diagram that I put together, right? So imagine it is being done for Amazon.com. So we all go and place orders in Amazon.com. The order gets routed to the most optimal warehouse, right? Because they have storage warehouse of all the different things that they sell. Depending on who is the person who is placing the order has to be routed to the nearest warehouse so that the total amount of money they spend in reaching those articles to people is lesser. So there is some algorithm or logic that runs in terms of picking the most optimal warehouse. Once it comes to the warehouse, a service person from there picks the order for fulfillment. So he takes the order, it is available in a mobile device. He has to go to shelves and pick up each of those individual items. Let us say, you find, somebody has ordered for a phone and a laptop and let's say some apparel. So they have to go and pick up each of those items, right? Firstly, each item has a UPC code on top of that. That is a passive IoT. If there are smart shelves, right, where we spoke about what smart shelves do. There is an integration into inventory. So when you pick up one article, it reduces the inventory. And then when it reaches the reorder level, it automatically places an order, etc. Right? So that is one area of IoT. And then you will actually, the person who is actually picking up those articles is going to scan the UPC using a handheld device. How does a handheld device look like? So this is the circuitry for a handheld device, right? Just like the circuit that we were trying to deal with, this is how it looks like. Only thing is it has been packaged to make it easy to hold, easy to carry, etc. So that this looks like a finished commercial product, right? So the barcode scanner is here. This is the circuitry, right? So you will build something like this, not necessarily using Arduino or using Raspberry Pi. Maybe you'll use a specialized thing for this. You will create a separate printed circuit board, considering what are your requirements and how to keep the cost low, etc. Right? You will consider all those things. So that's what goes inside this UPC scanner. So you'll have to build something like that. So while Pioneer actually mentioned about an optimization of supply chain. Optimization of supply chain is such a long process. Out of that, I'm picking up one item, which is a UPC scanner. If you have to build a UPC scanner itself, that is one circuitry, right? And then let's say he scans it and adds to the delivery card. The card itself can be smart, right? So today, you look at this. This is the Amazon cart, right? Amazon internally uses a cart like this, where somebody is fulfilling an order. They keep taking and putting it inside this. And the smart cart actually has an ability. It has a scale. It has an object counter. It counts the number of items as you keep putting, and then you can tally the number of items in the order versus what is there in this one, right? So in the cart. So if you take a simple use case, scanning the UPC based on that updating the inventory and fulfilling the status, that in itself is one use case. So this entire problem statement has to be first broken down into some 20 problems, 30 problems. Each of them have to be individually solved, and then you have to integrate it. Then you have a cart that you have to send it to dispatch. Meaning, for example, when the last item is being put inside it, you could actually send out a message to dispatch saying that for this order, all the things that are present in the order have been collected, that is coming for dispatch. So it can give an early alert to them. Then you can print the labels there. You can prepare the package, or if you are using a carton or a cardboard box to put together, you can prepare all those things. Right? Then the truck driver has to load it into that. The truck driver will use a handheld device to scan the overall package. He's not scanning individual items. The overall package itself has another UPC code. Right? So you can build another scanner for that. So this is the full supply chain. So if each of these areas, if you do not have these IoT devices, it takes so much amount of time and effort for you to complete that. This is a quest to try and make it efficient. Make it in some cases, depending on the type of problem that you are solving, it can actually become a safety use case, or it can become an efficiency use case, right? So I just, during the lunch break, I just put together something very quickly. If you see here, if I attach it to we spoke about OBD2 and telematics on vehicles, right? The board's schematic diagram is here. So this is the OBD2 scanner. This is an IoT label printer. So there are multiple devices which have to come together for you to optimize this overall supply chain itself. Okay. So anyway, so in that, we actually looked at only one or a handful of small examples, right? You have to build on top of those if you have to create an application like this. Okay. So I'll pause here. So that is all we had in terms of, and I'll send you this deck also. So that's all we have in terms of the content that we wanted to present.